What was the approximate depth of the water at 6 a.m. and
Good job.
what was the
We don't actually have to read the questions actually right now. In fact, the questions are not really that important to me. I really want to come up with a model for this of that kind of type, right? Like an equation that dictates the depth of the water at any given time t. And then once I have that, that will be like the order of power. I then come to me with any of your questions once I have that model in my hands. Okay. So let's see if we can develop a model. Let's start by maybe just trying to sketch a quick graph. You don't have the benefit of this piece of nice grid, sorry. So you can sketch your own. I have mine set up in such a way that I have like 24 grid lines here. So maybe you scale your t-axis here. Your t-axis, make sure there's 24 hours here. So this is 24 down here. So we can see a whole day maybe. And if yours actually, in some ways, I kind of wish I didn't have a grid. You'll see in a second why that's kind of a frustration for me, to have a grid. You might actually benefit by not having a grid. Because I'm about to plot these points, none of which land on the grid line. So that's like relative usefulness, my grid here. All right. So you like my scale? What do we want to call this axis? We didn't give names for this function yet. T makes an obvious choice for time. What about this? Height of the water or, okay. Which do you prefer? I don't know. H, D? Everybody fight. D or H? D. I heard D more loudly. Okay. D wins. Okay. I don't really care. All right. It looks like there are two data points kind of given. There's a time and a water depth, and then another time and a water depth. So that's good. And also, it's important that they list that those are the first high and the first low tide of the day. Yeah, in fact, those are maxes and mins, of course. That's an important thing to note. So let's see if we can graph these ever so slightly here. So 211 is in hours. That's a little, it's not 2.11 hours, right? It's 2 plus 11 60ths. So what is that? 2 plus 11 60ths.
Something.
No. 2 point something, I know that. About 2.18. Okay, so we got 2.18, so here-ish. Up here 1.9, so let's just say there somewhere. Okay, good enough. What about the other one? We got, that was high tide. Low tide is 8:14 at a height of 0.4. So what 8:14 do the same thing for me? What is it? 8 point something.
It's
8.87.
No, wait, that doesn't make sense.
Seems
wait,
less.
I did 16 instead of 16.
8 plus 14 60th is
8.2.
8.23. Did anyone else confirm these things that are coming from? Okay. 8.23?
Yes.
Okay.
Are you saying I'm not right?
No, I just don't know. I just wanted another voice. You're the only one, like, seems like you're the only one doing it, but I don't know. I'm sure there are other people. 8.8 and some change, so almost 8 1/4, and 0.4 is, I don't know, I'll say right around there somewhere. Okay, good enough. So we don't have a perfect picture, but we could start already kind of thinking about what this behavior looks like, something like that. Maybe we can come back and revise the picture if we don't really like what I drew. It's needs work. Definitely needs work. Are you ready to start giving me the equation here? We need 4 things. And I don't know. Can you tell me one of them? Volunteer if you know. Not just what it is, but how to calculate. They walk us through how to calculate, I don't know, whichever one you like. The amplitude, the spaceship, the period, any of those. Aiden's got one of them. Go ahead.
So to find the sinusoidal axis,
I like it. Okay.
you would take, because this is the middle point in the road, I think you showed us this, and this gets this one. Anyway, so you take 1.9, which is the maximum, and you take 0.4 meters, which is the minimum, and you subtract 0.4 from 1.9, and then you divide them by 2 to add them out, and you get 3/4 or 0.75, or 1.5 over 2, which is 0.75, and that would be y equals 0.75 would be your.
Wait. Someone slow down here. Let's see. Wait. So you did.
No, okay.
You did 1.9 minus 0.4 over 2, and you got 0.75. Is that what you said?
Yeah.
0.75 is the sinusoidal axis.
Yeah, I got that.
Oh wait, no. 0.4 plus 0.7 times sinusoidal axis.
Well, let's stop and say what you first obtained. What did he first get?
That's points. The amplitude.
That's the amplitude, right?
Oh.
The difference, half of the height between the 0.75. Sorry, you can't see that very well. 0.75 is half the total height of the wave, which is the amplitude, as we know. Good. So we got one of the letters. Could be another one. Yeah, Rob.
So we take, so to find out what B is, you would have to,
B? Are we doing the period? Or you're thinking about B, the B value? Is that what you said?
B value.
Okay.
So I don't know the exact value for the, but basically you take the first point we see over there and subtract it from the point we see at the other point.
The times.
Yeah.
You mean?
Times, yes.
Yeah, okay.
And after we get that, we just do 2 pi over x equals whatever that is, and then from there on we can solve for x by doing 2 pi divided by whatever.
Yeah. Okay. I need my calculator.
Period is 2 pi over 6.
Wait for it. Spin. All right, so what do we got? We got 2 plus 11/60ths.
Yes.
That's, I'm going to call that A in case I ever need it again. And 8 plus 14/60ths. Let's store that in B in case we ever need it again. And you're just now saying you'd like me to say it again, Rob.
So now what if we do B minus A?
Okay. And that will give us the distance from the time interval from the max to a min.
Right.
Okay.
And from there, what we do is 2 pi divided by that.
Wait, so is that what's the period? I guess that's only half the period.
Oh, no. What
B minus A would be half the period.
Oh, no, what I said is we take the two, like the two, I don't know.
So from a max from a max to a min, it takes 6 hours and
Oh, and then multiply
something.
by 2. Yeah, and then 2 pi divided by
All right, so multiply that by 2. People are saying so 2 times the difference between those. So 12.1 is the period. Why, in the context of the problem, does 12.1 seem like a reasonable period? 12.1 what? Hours. Why is that a reasonable period? It's like half a day, so makes sense because then we get 2 high tides on a given day and 2 low tides on a given day, which is what happens. So that makes sense, yeah.
Sorry, just to clarify, the period is from a max to a max, right?
Yeah, from a max to a max, or a min to a min, or any corresponding point on the wave to its next corresponding point on the next time around, right? You can measure it from anywhere you like. Okay, so yeah, now I do need to hear about how to find B again. What was that? Did you say B is equal to
so B is equal to 2 pi
2 pi over
over.
12.1, or if you wanted to write pi over 6.05, you could do that too. I just want to work out that algebra too. Is that really true? I thought the period was equal to 2 pi over B. But it's also true that B equals 2 pi over the period? Is that like a thing? Okay, period equals 2 pi over B. Oh, I think I see it. Yeah, B is equal to also 2 pi over P, the period. Okay, all right, I did some algebra. I got it. Good. Give me another letter. I'm ready. Sorry, that took a little while on that one. That's probably the trickiest one to talk about. So let's knock the other ones out quickly though. You got one, Reggie?
Oh, no. I had a question. So by finding the difference from the max to the min and the timing that by 2, like in terms of time intervals, that gives us our period.
Yeah. Yeah, from one max to the very next min would give us exactly half the period. So, yeah. So what was this time? 8.23. 0.4. All right. So give me another letter. Someone just go ahead, Gail.
C will be.
What's C?
Oh wait.
Oh, a phase shift.
No,
Okay.
phase shift will be 5.21.
are you gonna use a sine graph or a cosine? What are we doing?
I was thinking sine graph, but for cosine it would be
Because you actually had to calculate this
Oh, yeah.
point here. Is that what you did, or
yeah.
something?
I feel like I just realized it'd probably be easier if I just did the cosine graph. So then
Where do you want to shift it to?
To the first point, so 2.18.
Yeah, go for the low-hanging fruit there. Okay, I like that. What else do we want to say? What were we missing? Yeah, we need the sinusoidal axis. The vertical shift is, what was that then? How do we get that? Yeah, you could do that. Plus 0.75. What does that come out to be? All right, so we're ready to write the equation here. The other way you can get the sinusoidal axis from the front of the problem is just to average these two, right? Average 1.9 and 0.4. Add them and divide by 2 if you want to. Anything correct is okay. So. All right, here we go. We're calling this d of t. It's 0.75. What function are we using? Cosine, because we've talked about the phase shift. We kind of lock ourselves into that. Pi over 6.05 times t minus 2.18. We'll write that, but we know that's actually a rounded value plus 1 point. All the other values in this problem are all perfect. This one, I just want to arrow it there. That one's not quite perfect. Okay, so I just want to make sure that when we go to the calculator, I'm going to put this in y1. You guys do the same. Just make sure that you're aware of that and you put in the perfect number. I think that would be the right thing to do. So here we go. 0.75 cosine pi divided by 6.05 times x as a stand-in here minus, how would I use alpha a, because I already have that value stored in there, 2.18 plus 1.15. How you feel about this, friends? Before we go graphing crazy, let's hit the window up. What do we want for the window? Look at the graph we made. X we want to be, that's hours, that's time. Maybe 0 to 24. Y, it makes sense to have that go from maybe 0 to 2, or I don't know, maybe we'll give it a little extra something. There we go. Okay. Looking good? Let's just verify we're not crazy. Let's trace that to, how about trace to A? Is that what we want to see?
Yes.
2.18 comma 1.9. Beautiful. Let's trace to B also. Is that what we want to see? Guys, we could not be wrong, right? This is perfect. This is what we want to see. It's got to be right. All right, now we're finally ready. We're finally ready to answer the questions. What's the first question? We want to know what the depth is at
6 a.m. and 1 p.m.
All right, so trace to 6. Write that down, 0.850 to 368 meters. And what else? 1? So we type in 1.
13.
Oh, 13 is what 1 o'clock is? Oh, okay. Write that down, 1.74 meters. That's the answer to the second part of A. Now we need to turn our attention to B. What are we doing there? A little trickier, but yeah, we need to think about where the depth is 1 here. So graph that. And is there a feature that can help us with this? Intersect. First curve, yeah, the blue one. Second curve, yeah, the red one. Guess? That's a bad guess over there. What do you think the guess is? 1, 2, 3, 4, 5 maybe? You want to guess 5? Boom. 5.596 to 36. Well, wait, hold up. Maybe we don't want to just write that down. All right, calculator skills. You ready for this? Okay, that's really the thing that's still showing on your screen. You haven't traced left or right yet, right? It's still blinking there? Good. Go back to your home screen. Calculator skill. Life skill here. Okay, really. If you type in X right now, it currently stores the value. Unless you trace left or right, then all bets are off. If the very last thing you did was found that intersection, you go back to the home screen, type X, it will hold that value. Just second mode. Second, hit quit. You're back home. Good. Why do I care about that? Because what I'd like to do is report my answer as maybe minutes. So how do we do it? What do I do?
So then you just put the decimal value on whatever that is, so just maybe -5.
Okay.
Because you already know that the hour value is 5, so you'd say 5 o'clock. And then, is that right? So, oh, no.
Yeah, certainly it's between 5 and 6 a.m., right? Yeah, keep going.
So how I would set that up is like that over 1 is equal to like x over 60.
Yep. Yeah, absolutely. I agree.
And then we would just do, I'm not quite sure, you just multiply by 60 to get the minutes, right?
Yeah, so that's the number of hours. It's like 0.6 hours. Yeah, so how many?
So then it would be like 5 and whatever that is to like a.m.
So it's 5 hours and then 36 minutes or something. So 5:36 would be the closest minute, right? But a little before 5:36. You could do this process again.
Or like 5:36.
And you could find it to the nearest second if you like, but I think 5:36 is a decent answer. Let's write that down.
It's a.m., right?
Yeah, a.m. Oops. 5:36 a.m. And we wrote these answers down, but you got them, right? Okay. Questions, thoughts on that? I think it's good to go through all that. Like I said, the bulk of the time we just had, just now 10 minutes or so, was spent on coming up with a model, and then we spent like really just a minute or two answering the extra questions. The crux of the issue is, can you come up with a model? In fact, that's all that the second one that here asks you for. Yeah. All right. Read this one for us too, Antonio. Go.
The average monthly temperatures from October 2007 to October 2008 for Scotland are shown in the table below. Give a sinusoidal model using 31 as the minimum and 66 as the maximum.
And even if they didn't tell you that last sentence, I think it would be pretty clear that that's just in the table. You can see that that's a minimum and that this is a maximum. So I'll give you a second. Figure out the 4 things we need. I'll call on anyone whom I like in about 2 minutes, and I'd like to have those 4 numbers. Call on whoever I like.
Sinusoidal just means sine, is it sine or cosine?
Yeah, sinusoidal always means either sine or cosine. Okay, whichever you like.
Is there one time the sine constant of the line and this is just time the square?
Yeah, and that's what Kim did was not what the number is. She was looking at 5.
So you kind of add it as well.
So you have to find the place in between 5.6 or 8.23. And then you shift it there.
Okay.
You have to do it negative. You'll see the average of those two. A and B. But don't do that because, you know, just go for the lazy hand. Yeah, you'll stay with the amplitude so long as remember the right back to the equation. A will be like, well, it'll be your choice, right? Like in the one. Some people say, oh, negative 301 out front. Some people say 3. Depends on your phase shift. Right? Because if you're shifting to a minimum, you're going to have a negative up front. If you're shifting to a maximum, that's cool. You don't need a negative because cosine starts at a maximum. So it depends on what your phase shift is. But yeah, do the other things and we'll come back to that. You know, you don't have to make that choice right this second. Oh, I should have Antonio read it in a Scottish accent. That would have been really. Make sure you calculate the radius. I just want to compare. I think ours is actually really good, too. I think this is all, you know, I think it'll be very good. Maybe better, I don't know. All right, I'm going to call on some people here. Give me one of the 4 things we need. Ivana, start us off with something, anything.
So we need the amplitude.
All right, we're coming back together here. So she's got the amplitude.
The amplitude is just,
Okay.
well, it's, oh, wait, I actually set it up. Okay, so it's 66 minus 31, which is 35. And then, you have that because the amplitude isn't the full, like with
Okay, guys.
it's just half.
Kill the side conversation for now, please. Thank you.
So, yes, you would have the difference, which is 17.5 degrees.
17.5. You guys agree that's what you got for the amplitude?
Yeah.
Okay. Catherine, give me something else. Hey guys, thanks, Mike. Phase shift. What'd you say it is? 3 if you're shifting to here. Okay, so you get to make the choice for us. We're all doing what you say. All right, we're shifting to here, everybody.
Right.
I don't know. That's just the letter we use. I mean, doing something else. You got the. What are we missing? Sinusoidal axis or the period?
Period, I got period is 12, so B equals pi over 6.
So B is pi over 6 because the period is 12, he says. Which again is not a huge surprise on this problem. That like this time we're talking about not hours, but 12 months makes sense that hopefully like temperatures are periodic throughout the year with a period of 12 months, right? So that I can buy that.
Also, that's how you know what makes our period 12.
No, you can also calculate it.
Oh, yes. So
6 is half the period. So the period is 12. Aiden, you get stuck with the last one here. Give us the, what are we looking for? Sinusoidal axis. 48.5. 48.5, agreed. Is that what you got? 48.5? Okay. All right, so here we go. Let's write it here. What are we going to call this? How about T of T? You like that? Okay. 17.5. What cosine? It has to be a negative? Oh, yeah, because Catherine made us a choice here. She said we're going to shift to 3. All right, so yeah, we got to do that. Negative cosine pi over 6. And in parentheses T. What are we doing? Minus 3 plus 48.5. Problem done. Jonathan, how are we doing over here? I had Jonathan doing the sinusoidal regression using all the points on the calculator. Did you get it? You get it?
It's a sine.
All right, go ahead.
16.657 sine of 0.524 x plus 3.107 and then plus 50.
Plus 50?
Yeah.
I claim that we're really close. Actually, you might have to rewrite this as a sign. So you convince yourself that we're pretty good, actually. Homework 3 tonight. I mean, question. Yeah, absolutely. Yeah, exactly.